welcome to this section. In this video, we'll be discussing how to evaluate Pascal's triangle and how to make use of it for binomial expansion. So, first thing is first, all you have to do is just find this triangle. It's on the, or draw it for yourself. You don't have to draw the hexagonals. All you have to do is put ones down the diagonals on the outside of the triangle, just the edges on the left and the right, and just leave a gap in between them. You can find this on the Word file. I've provided the Word document at the beginning of each section here. It has it there. So you're going to just simply take those two ones there and add them together like so. So the first these two ones on the top give you a 2 in the middle. Then you have more ones on the side, so the 2 and a 1 make it 3. The 2 and a 1 make it 3, and so on and so forth. Just have a go at this. It's a simple exercise. You don't have to go beyond the 5th row here. Now, why are we doing this? What's the point of this? Do you recognize any of these patterns across a row here? Like 1 to 1. Do you not recognize it? 1, 3, 3, 1. Alright, if you don't, let's go through it. Look, anything to the power of 0, I think you agree with me, is a 1. If we multiply that by a plus b, we just have 1a and 1b. If we multiply that 1a and 1b by another a plus b, we end up with a squared plus 2ab plus b squared, don't we? And do you recognize the coefficients here? What we had there on the table are these coefficients here, right? Of course, the a and b weren't there, but what you should have in front of you with the Pascal triangle that you just filled in is these coefficients here. And the next bracket here, the a plus b cubed, is a plus b squared on the line above it that we just evaluated, squared, multiplied by a plus b again. So a plus b squared times by a plus b will give you, and we did evaluate a bracket at the beginning of the prior knowledge test where you had a negative sign, you had a plus minus sign alternating. That was the only difference, and I'll show you how we will get the alternating signs in the next section. But just for now, our knowledge is just for you to understand. Our work here is for you to understand that the fact that these coefficients match with the row above being added to each other, like why is it that this 1 and 2 here, the purple 1 and 2 add up to 3, and then this 3 and this 3 add up to 6. It's like a trickle-down effect, isn't it? If you understand what trickle-down effect is when raindrops like drop into the lower layer one step at a time, at one layer at a time. It's because you're adding coefficients really. Once you multiplied them and you're collecting like terms, you're adding coefficients that will add up to 3 and so on and so forth. So these coefficients of binomial expansion, then you can take it out of the Pascal's triangle. All right, so in the next section we just have to use the Pascal's triangle to evaluate these expansion of brackets. I must say it is not the only way. You don't have to draw Pascal's triangle, but it's just showing you how it's done. So for example, let's say we already evaluated the Pascal's triangle here and we want to expand a plus x now, or 3. So what it is that I'm just trying to help you understand that when you have when you are expanding here, you will have to collect like terms where ax squared. Well, there is just one way of writing a cube at the beginning, right? At the beginning of that expansion, we'll have a cube, and because there's one way of writing it, its coefficient is 1. This green line here is what we're going to look at because the power is 3. We're ignoring that. That's 0 zeroth row. All right, so this is really our first row. This is our second row down here, and this is our third row that we're looking at. We're looking at, I call this third row. The book actually calls it the fourth row, but I don't know why. So let's just look at, when you have expansion of that bracket, you could have a times x squared written like so. You could have a in the middle, and you could have a in the end. So there are three ways. That's why you can think of it as there's three ways of writing that. That's why the coefficient is 3 there. Now, how many ways you can write x times a square? You can write it like three ways again with these combinations where you got two a's multiplied by one x. So that's why you get this 3 here and this 3 here. And finally, there's only one way of writing x cubed, isn't it? So that's why the last coefficient is a 1. So those threes are indicating that how many ways can we rearrange the writing. So I'm trying to expand this bracket for you using the Pascal's triangle here. So I've taken the color coded the answer here, so you know that this 1331 is coming from that row there. Okay, so, and you have exactly four terms once you've expanded the bracket. There is no way, if you got like five terms or less than four terms, you've made an error. Just go check your work. And once, while we are here, you might as well notice that each term, we call these terms where you have plus minus signs. This is algebraically, this is one term. Okay, and each of those terms, the powers add up to what? Think about it. These two powers add up to 3. Add up to 3. This is 3 already. This is 3 already. And same works with every other expansion. We look into that next. So just writing it out neater, you'll have, we don't have to write the powers when there is power of 1. Yes, and you don't have to put the coefficient of 1. So we omit the ones in algebra. This one at the front, in front of a cube, and x cube is omitted, and the one as a power is omitted, because you don't have to write it. Everybody understands power is 1 when there is no power. Okay, so in this next example, once again, we're still looking at the Pascal's triangle here. So we've been asked to find the coefficient of b squared in the expansion of a plus b to the power of 4. Now, why did I go straight and circle that 6 for you? Because we're looking at the fourth row here, and the power here of b is saying that how we actually, let me say one more thing, is that this 4c2, 4 is on the top, c here, and 2, you can find this button on your calculator. This, we read it as 4 choose 2. Okay, 4 choose 2, that c stands for combinatory, combinations. You could think of it either way. Some math teachers say that's 4 choose 2, or that's 4 combinations to, I don't know which is the correct way, but that's the letter mathematicians gone for, just to indicate that that's actually, like, I'll explain factorials in more depth later, but that 2 at the bottom of 4 choose 2 indicates the power of the our term here. Now it's symmetric. If you write the expansions here of a square b square, all right, this is one of the terms in the middle, and the powers have to add up to 1. So this term is like exactly in the middle, because there is no there is, if we switch a square with b square, it's still the same term. So now this stands for a to the power of 4. That's the coefficient of a to the power of 4. This is a to the power of 3, b to the power of 1. So that 1 here matches with the power of b, and that 2 is matching again power of b. It's symmetric, all right. One thing you notice is this 4 is the same as that 4, and 4 choose 3 is the same as 4 choose 1, because the numbers in front of a to the power of 1 b cubed is the same as a to the power of 1 b cubed is the same as a cubed b to the power of 1. Alright, so notice the symmetry here as well. And this last one, notice the powers of a were going down, so we will have no a here. You could think of it as a to the power of 0, b to the power of 4, if you wish, but there is no need to write a to the power of 0 because it's a 1, and 1 times anything is still 1. So finally, if we had to expand it, we just write a 4, we put plus signs finally in front of each of these terms, and that would be our answer to expansion here. But the question, if you read it carefully, was just asking what's the coefficient of b, the term with b square. So they wanted us to find this 6. Okay, so let's look at yet another example here. We've been asked, so these are more like questions you'll be asked to answer. Find the expansion of x plus 2y cubed, right? So we have that Pascal's triangle. You must have made a note of it by now. So you could think of it as Ra is x, Rb is 2y. Now power n is 3. You must be careful. Look, we're calling b to y because there is an extra coefficient we have now in our bracket that wasn't taken care of previously in any of the examples we looked at. So there is something extra that you have to be careful here. In this expansion here, in this row, it's going to be the third row, and when b is 1, you just have 2y. But when b is raised to the power of 2, you must be very, very careful, because most students, I've seen this time and time again, in exams, they get the answer wrong because they forget. They just write 2y square and they write 2y cubed, and they think, all right, now it's time to multiply. I did multiply 2 and 3. Well, it's wrong, because this 2 needs to get the power of 2, and this 2 needs to have power of 3 on it. Okay, so please make sure you use brackets, so you will brackets to make sure when you evaluating powers here. All right, so the final answer will be 6x squared y plus 3 times 4 is 12. You, yes, I know it's a lot of writing here, but that's how it's done correctly. All right, so notice this line here with these 4 terms. The coefficients are not symmetric anymore. All right, that's fine. That's because that 2 is doing its job here and making it unsymmetric here. So the coefficients were symmetric here, that's fine, but because of the 2 inside the bracket with the power, yes, you don't see any symmetry in this answer here, but that's the correct answer. All right, so let's look at the next example here. So we've been told that expand 2x minus 5 to the power of 4. So this time you're looking at the fourth row here. Just think what you're going to substitute for a and b. All right, there's no right and wrong answer. You could have called this b. You could have said b is 2x and a is minus 5, but does it will give you the same answer, only in a different order. So usually, yeah. So we're just gonna take a to be power of 4, so 2x needs to be raised to the power of 4, and so on. You're just doing a simple substitution here. Every time you see a, make sure you use a bracket and raise the 2x to the power of that uh, value of a. Now it's time to evaluate them. You can use your calculator and whatnot, and to write so many lines, you can jump from this line to this line here, but I would definitely write this line here. if you don't write this line here, you're risking getting the answer wrong, and I wouldn't do that. Okay, so then after, yes, it does help to have something to look at this formula to know what you're substituting. But in the next exercise, you actually in exercise C8C, you learn how to go straight to the answer if you don't know the Pascal's triangle. So yes, I know Pascal's triangle involves you actually adding numbers up and trickle them down. But anyway, so let's finish off this question here just to finish this up. Actually, these last two lines are exactly the same. So next question, you've been told that the coefficient of x squared in this expansion is 294, and you're asked to figure out the value of the constant c there. Notice I'm calling it a constant because the only variables are x in this expansion here. So we're gonna work backwards from the which row are we going to look at in the, because this is the power here is 3, we're looking at the third row here. Okay, so we are looking at this row here. Now they told us x is squared, therefore either you can say x is the value, like a negative cx is our a here, or negative cx is b here. So doesn't matter which of those terms you take, either one would do. But make sure you raise x together to the power of 2 here. So you're using a bracket here, and that minus sign goes with the second term. All right, obviously the sign comes after the 2, so it doesn't belong to the 2. It belongs to the cx. So we're going to square that, and we are taking this term. That's why we put in an extra 3 at the front. And where did that 2 come from? 2 was our value for, so we're saying a is 2 here, and b is minus cx. All right, that's what we said. That's our one of this value here at the front is instead, it could be a variable, now it's a constant. Now all we have to do is set this equal to what? Set this equal to 294 and solve it. So x, whatever to x, we can drop it off because we just dealing with coefficients. Okay, coefficients. So this, you can just ignore we're not solving an equation here yet. So there are two unknowns here. You cannot solve this if you put x into your answer and trying to set this equal to 294. The word in the problem said the coefficient of x squared. So if you want to write it, you can write it as 294 x squared. Divide both sides by x squared. Cancel them away. So you get this line here. All right. So I've seen some of the students they keep x here, and they don't know what the x value is, so they can't evaluate it. Now all you have to do is divide by 6 and square root both sides. So dividing by 6 we have 49, and that's plus minus 7. Can it be minus? Well, it can be, yes, because the question didn't tell us or negative. So for this first, yes, you do have to use your knowledge of the Pascal's triangle. So go ahead, have a go at this exercise, and I'll see you in the next video.